Smoking gave me COPD, which makes it harder and harder for me to breathe. I have a tip for you. If your doctor gives you 5 years to live, spend it talking with your grandchildren. Explain to them that your grandpa's not going to be around anymore to share his wisdom and his love. I haven't figured out how to do that yet. And I'm running out of time.
You can quit. For free help, call 1-800-QUIT-NOW.
Hi, I'm Walt Marshall. You're watching the Fayetteville Public Access Television.
Hi, with us tonight is Dr. Claude Lacey from the University of Arkansas. Claude, how are you?
I'm well.
Now, Claude, you're an astronomer in the physics department.
Yes.
And one of the things I guess I wanted to talk to you about tonight was Pluto. And there's been moral outrage across the planet lately because Pluto was, recently, downgraded?
Reclassified.
Reclassified. A lot of people think it was disrespected. Can you tell us how it's been reclassified, though?
Yes, it's been reclassified as a dwarf planet rather than a regular planet.
Now, what does that mean, though?
Well, a planet is an object that's orbiting the sun and that's big enough, massive enough, that it's been pulled into a round shape by gravity. And it's also cleared all of the objects out of its zone. So that means, because Pluto hasn't cleared everything out of the Kuiper Belt.
What's the Kuiper Belt?
The Kuiper Belt is a region beyond the orbit of Neptune, where there are a number of bodies, including one bigger than Pluto, that has a moon, in fact. It's called, I wrote it down, Eris.
Is Eris a planet?
Eris is a dwarf planet.
Like
Pluto,
okay.
And also Ceres, which used to be called just an asteroid, falls under that classification. Now it's a dwarf planet as well. So there are 3 dwarf planets and 8 regular planets now.
So all these planets we had to learn as kids now, all that's changed.
Well, just the last one.
Okay. So we have the 8 regular planets, then we have the 3 dwarf planets at the very end of the solar system.
Yeah, I guess you could put them in the rhyme somehow. I haven't tried.
So is there a reason that we have the dwarf planets at the end of the solar system? Or is that just the way it worked out?
Well, Ceres is actually in the asteroid belt, but Pluto and Erin are in the outer part of it. And that's because the outer part contains a lot of debris left over from the star-forming process that made the sun, and that debris is still fairly unconsolidated. So there are some fairly big chunks like Pluto and Erin, and a whole lot of smaller chunks that are still floating around out there.
Yeah, but is it normal for a dwarf planet to have moons? Because Pluto has moons.
Pluto has 3 moons.
I don't mean to be plaintive here, because I know when I went on the internet this week, there's a lot of whining about Pluto. I mean, I couldn't believe how much whining there is about Pluto. But I mean, Pluto has moons.
Pluto has 3 moons, yes.
Right.
One big one, about half the size of the planet itself, called Charon.
So just speaking for those poor people who can't be here tonight, shouldn't that say something for poor Pluto?
Yes, but Erin has a moon too.
Oh, okay.
And it's bigger than Pluto.
Okay.
So it's either add Erin or create a new class, I guess.
Oh, okay. So does Neptune have some kind of influence over Pluto?
The orbit of Pluto actually comes closer to the sun than Neptune does. In 3 space, the orbits go like that, so they don't actually cross. So they couldn't actually collide today.
Right.
But I wouldn't be a bit surprised if 4 billion years ago, maybe they did then, and since then the orbits have separated.
Okay.
So it may be that Pluto started off as a moon of Neptune. I'm not sure.
So this joke I'm making that Pluto is just a weak-willed ninny who's just heavily influenced by the big kid isn't totally accurate?
Maybe something to that. Yeah.
Okay. Speaking about that, when we talk about these planets, though, how long have we known about the other asteroids, the other dwarf planets?
It's only fairly recently that we've been discovering these large objects in the Kuiper Belt out beyond Neptune.
Why is it only recently?
Well, they're faint.
telescopes,
They're
or-
really faint. It takes big telescopes, and we've been getting more big telescopes lately. It takes big telescopes and good seeing.
Now, how long does it take Pluto to orbit the Sun?
About 250 years.
Really?
Yeah, 250 years is 1 year on Pluto.
Wow. Okay. Okay. So, do you think there's just? Why do you think there's so much? It seems to me. Do you think there's some anger? I mean, why do you think people are so upset about Pluto not being a full planet
Well,
anymore?
they become attached. You know, they know about it, and they've known about it for a long time since their childhood. And so when you know, it's like, don't demote my Pluto.
It's my planet.
Yeah,
It's my favorite Disney character.
right.
So, but I mean, I read this also on the net. It says, for nostalgia's sake, shouldn't Pluto still be a planet? You know.
It wouldn't bother me if you called it a planet, even though I am a member of the International Astronomical Union that declared this.
Now, what exactly is the International Astronomic Union?
It's the International Astronomical Union. It's an organization of astronomers who have the responsibility of doing things like naming new objects and naming new craters and classifying things.
Now, when people think of astronomers, I understand there are many different categories of astronomers.
Oh, sure.
I mean, I guess the popular conception of an astronomer is just someone who maybe go to Mount Palomar or something. That's what we would think of when we were little kids. That's the big telescope we all knew about. You know, just someone who gazes at the stars. But I understand that many astronomers have many different categories. So how many categories are there, or there's just too many to mention?
Oh, well, I guess there's two broad categories. There's the observers, who are the ones that go to the telescopes or program the robotic telescopes to do their work while they sleep. And then there's the theoreticians that try to make sense of what the observers find.
So what category would you fit into?
I'm an observer.
So the IAU, how do they go about this decision of deciding Pluto? I mean, I understand like a small number of scientists made this decision.
Yeah, the organization is broken up into working groups, and the working group that's responsible for classifying solar system objects got this assignment to determine, you know, whether Pluto should be considered like the other planets or whether it was somehow different and should be reclassified a few years ago, and they just came to this decision fairly recently.
Do we have any probes or anything going toward Jupiter?
There is a space probe NASA launched towards Pluto, and it'll get there, I think, in the year 2015.
I say not that long. That's not that far away, is it?
Well, I don't know. I brought some toys with me
Oh,
to
cool.
show you things like the size and distance scale. So
Now, what does this represent?
this would be the Earth. So if the Earth were that size, then how big would the Earth's moon be?
About this big?
The answer is
There you
about
go.
this big,
Okay, tennis ball.
size of a tennis ball.
Okay.
And what would be the distance between the Earth and the Moon, you think, to this scale?
That's
Would it
about
be
what
this
about?
close or that close?
Not that far away. Maybe 4 or 5 inches.
Correct answer is 30 feet. So it would be all
Really?
the way across the studio, 30
Really?
feet away.
At
If the Earth
these
was
sizes,
this
30
size.
feet?
Yes, 30
Okay.
feet.
Wow. Okay.
And then I've got Pluto here, little Pluto,
Right.
which used to be a planet. It's now a dwarf planet.
Now, is this a direct comparison to the size of the Size of the Earth there, or size of the Moon?
Yeah, it's
So
the
that's
same scale.
so that's about three-quarters of the size of the tennis ball.
It's
Okay.
smaller than the Earth's moon. It's
Okay.
a planet.
So that's,
used to be a
that's
planet.
right next to the, so people can see. Oops.
Yeah, I don't know
Let
which
me see.
camera's got it right now.
Let me see if I can put that right. Let me hold that. Jeff, can you see that? There we go. Okay, right there. There we go. That's about
It's the
three-quarters of
Earth's
the
moon
size
and
of the
Pluto.
Okay.
So it's smaller. Pluto's
Okay.
smaller than the Earth's moon.
Okay, smaller than the Earth's moon.
And how far away would Pluto be from the Earth to the scale? Where would Pluto be? And the answer is
Half a mile.
Salt Lake City,
Whoa, okay.
1,000 miles away
Wow.
at this
okay.
scale.
Okay, that's okay. Okay. So is the probe going to reach? Is the probe going to reach Pluto?
It'll get there, but it'll
Okay.
take it a few years.
Now, what will the probe do when it gets there?
It'll take pictures. I think it's just a flyby, so,
So it's not going to land.
It's not going to land.
Is there anything to land on when it gets to Pluto?
Yes, Pluto is an icy, rocky surface. It does have an atmosphere, at least when it's closest to the sun, it develops an atmosphere of nitrogen, mainly. And, but it does have an icy and rocky surface. The average density of Pluto is about twice the density of water. So it'll be mainly ice, I think, with some rock in it. So it would have a solid surface. You
What
could
would the
stand
average?
on
What
it.
would the average temperature be on Pluto?
It's about 40 degrees Kelvin, where 0 degrees Kelvin is as cold as anything can ever be. It's absolute zero.
Wow. Okay.
So it's 40 degrees above that. So it's really cold.
it's really cold. So.
Really, really cold.
So will it? Oh, I was going to ask a stupid question about the space probe, but I mean, I'm not going to ask that. Okay. All right. Anyway.
It will be powered by radioisotope decay, so
Okay.
it'll be kept heated.
Okay. What can you tell us about moving away from Pluto? You do a lot of work with the Arkansas Center for Space and Planetary Science, which
Yeah.
is located at the University of Arkansas.
Yes.
Now, what exactly is that?
It's an organization of faculty and students that do research in the field of space and planetary sciences. We are in a number of different departments, about a dozen different departments of the university. So I'm from physics, but there are people from engineering and biology and all different fields that are represented in the center. We make proposals to various places, the biggest one of which is a $425 million proposal to NASA to
Yeah.
send the Harris spacecraft to get a sample of an asteroid and return it to the Earth.
Now, what can you tell us? What exactly is the Harris spacecraft?
It's a probe that would be built by the Jet Propulsion Lab, and it would have a sampling mechanism that would allow us to get samples of the surface of the asteroid and load them in a return capsule and then return them to the surface of the Earth. They would be analyzed by us and other people.
That's pretty amazing.
Yeah, it's a neat trick if you can do it.
Do you think you can do it? You obviously think you can do it.
We think we can do it.
So how many people are involved in this then?
Oh, well, lots. There are several of us that are on the team here at the university, many more that are located at various other institutions in the U.S., including a lot of people at the Jet Propulsion Lab.
How close is the Harris spacecraft to being built?
Well, it's got to be approved first, and we're in that process right now, and we should learn, in fact, sometime soon whether we've been selected for the next stage of development.
So who has to approve it? NASA?
NASA. It goes through a number of stages before it finally gets built.
So what's the time frame then?
Well, if we get through to the next stage, we'll have about half a year or so to develop a lot of the details that need to be known about, just how big is this piece and how heavy is it and what does it do exactly, and we have to specify very exactly what everything does.
And after it's launched, what's the time frame after it gets launched?
It would take a number of months for it to get to the target asteroid, and then it would do a reconnaissance, a visual reconnaissance of the asteroid watching it as it rotated and picking out the best spot to pick up the sample from. And then it would swoop down and pick up the sample, hopefully successfully.
Now you say that the spacecraft would do that. Would you be doing that from Earth watching, or would the spacecraft make that decision? Or would you?
It would be given the command to do it, but then it would be in charge of itself as far as what it has to do to collect
Okay.
that sample. It
Okay.
could not be remotely controlled because of the speed of light. It would be so far away that it just couldn't respond in time if you tried to use a joystick to control it or something like that. It has to be smart enough to take care of itself.
So, obviously, you have great confidence that this can be done.
We believe it can. We have actually landed a spacecraft on an asteroid. You may know the Near Shoemaker spacecraft
Right? Yeah.
landed on Eros. So we're pretty sure it can be done.
What about the? Okay. What can you tell me about eclipsing binary stars? Well, that's a whole. That's like opening up this can of beans. And saying, what can you tell me about this?
I love them because it's just such a remarkable phenomenon that you can have two stars orbiting each other and blocking the light. And it looks to us just like a single star because it's so far away we can't tell there are two there. But the star blinks in this characteristic way and it repeats itself perfectly. So we know what's going on. And by analyzing the way in which the light drops off during the eclipses and getting spectroscopic information, we can determine basically everything you ever wanted to know about stars and such systems.
See, so how can you tell it's an eclipsing binary star? I mean, how can you? What makes you suspect it's an eclipsing binary star?
The first stage is discovering them, and you discover them by finding a star that gets fainter in this characteristic way. So you take a series of images, and if you compare two images and a star looks faint here and it looks bright there, then you've got a candidate. But there are other things that can make stars get brighter and fainter than eclipses. So you have to figure out what kind of a variable star you have. If it is an eclipsing binary, then the next step is to figure out what the orbital period is. How long is it taking them to orbit each other once? And you have to know that very exactly. We typically know them to about 8 or 9 decimal places.
Really?
Yes.
So what sort of telescopes do you? I am assuming you're using telescopes, right?
Yes, this is all telescopic work, and small telescopes can do some of it. They can measure the light curves.
When you say small telescopes, what are you talking
it's all
about?
relative, isn't it?
Yeah, it's all relative.
Small telescope has
a
a mirror about this size or so. This is the smallest one we're using for this work. It's a 10-inch aperture telescope. And that can get down fairly faint, but if you have a really faint one, then you need a bigger telescope. We use primarily robotic telescopes to do that kind of work.
So do you have robotic telescopes here?
We have a robot on campus. It's on top of Kemple Hall. It's called the URSA telescope.
Now, how big is that?
It's a 10-inch diameter, so the mirror's about that big, and the tube of the telescope's about that long or so. And it sets inside of a little robo-dome that keeps the slit opening in front of the telescope all the time.
Is that what's referred to as a robotic web scope?
It is a robotic web scope, yes. So you go to a web page and specify the observations you want it to make for you. And in fact, our students in the introductory astronomy class do this.
What, they make the observations for
Yeah,
people?
we have something like 500 students a year that make observations with this telescope.
So who requests the observations?
They do. They go to the web page and they request what observations they want. After the telescope has made the observations, it sends them an email and says, "Okay, I got your data."
Really? Do people from other places email you and want observations?
They've done that in the past, yes. And we have a larger robotic telescope in New Mexico that we use for fainter things.
How did a robotic telescope come to be created? It just seems amazing to me you'd have a robotic telescope. Is this hard to imagine?
Well, it was an idea whose time had come. We had the necessary hardware and software to do it. You just have to be able to tell the telescope to move to a particular location, and you have to be able to compute, what location you need it to move to at a given time. And then you just have to track as the Earth spins to keep the object centered. Then you just have to make your exposure.
Is that the only telescope here in Fayetteville, or are there other telescopes here in Fayetteville?
Oh, there's lots of telescopes in Fayetteville. Most of them owned by amateur astronomers.
Well, I mean,
But as far as a robotic telescope, that's the only one we have here.
what other telescopes are there at the U of A?
We have some visual telescopes that we can use for star parties and such.
What's a star party?
Oh, a star party is just it's a gathering where people come to view the objects that are up at a given time with a telescope.
So, how long have you had this robotic web scope? Is
Earth-
that the proper name, robotic web scope?
Yeah, we just call it a web scope.
Okay.
We've had the Ursa telescope since the year 2000, and so it's in its sixth year of operation now.
Okay. You do a lot of research into stellar evolution.
Yeah, we use eclipsing binaries as a tool to check how good the theory of stellar evolution is.
Now, what is stellar evolution exactly?
Stellar evolution is just the theory that tells you how stars change as they age. So it's not like biological evolution, where one organism generates successors and so forth.
Right.
It's just how stars change as they age. So stars start off with a certain mass, a certain size, and as they get older, they start swelling up a little bit and getting a little brighter, and then eventually they swell up very fast and get very bright. And we check the details of that theory by measuring the masses and the sizes and the luminosities of the stars in these eclipsing binary systems with great accuracy, better than 1% accuracy these days.
When you say they swell up very fast, what is very fast?
Oh, it's all relative, isn't it?
It's all relative.
I say
isn't
that
it?
a
Yeah.
lot. Yes, the sun has been swelling up slowly for the last 4.6 billion years. It'll continue to do that slowly for another 4 or 5 billion years.
So that's pretty fast, huh?
No, well,
Okay.
that's the slow part.
All right, the slow
and the
part,
fast
okay.
part, it'll swell up and become a red giant over a period of only something like 50 million years.
Okay.
But it will have taken 10 billion years for it to get to that point. So the initial swelling is slow, and then it swells up very fast and becomes a red giant.
Okay. So, of course, you're watching things that have happened sometimes millions of years ago, aren't you?
Sometimes billions of years
Billions
ago.
of years ago. So,
Space is a time machine.
right. I was just going to
Looking out in space, you're looking back in time.
I guess does that ever fill you with a feeling of awe?
Yeah, initially. I've been doing it for so long, I'm pretty blasé about it
How
now.
long have you been doing it?
Oh, I guess I started considering myself a professional astronomer when I was in graduate school at the University of Texas at Austin, about 1973 or so.
What truly excites you about the stars? Or is there anything you said blasé, but are you truly blasé about everything?
No, I'm always excited when I start working on a new eclipsing binary, because you don't know what you're going to get. It's like Forrest Gump,
Yeah.
You don't know what you're going to get. And sometimes the previous work that's been done has reached conclusions that are just totally wrong.
Really?
And yeah, totally wrong. Like they list the orbital period with 8 digits of accuracy, and it's just totally wrong. I mean, it's not wrong in the 8th place or the 7th place. It's wrong in the 1st place. It's just totally wrong. That's fun.
Do you just want to call them up and just tell them that?
Oh, they're usually dead. The people that did that work are usually dead by now.
How do you deal with that? You must be excited though when you find that out.
Oh yeah. It's really cool to discover new things that are not known. You're the first one on the planet to know them.
Yeah.
And of course you want to tell other people, so you publish.
Yeah. So you study what are known as near-Earth objects.
Yeah, near-Earth asteroids, and some of them are probably burned-out comet nuclei.
Now, when you say near-Earth objects, there are people in the audience right now going, does this mean that objects like are narrowly missing the Earth or what?
In fact, they do.
Narrowly miss the Earth?
Often you hear about them coming closer than the distance to the moon. And it's not an unusual occurrence for that to happen. And occasionally these near-Earth objects will collide with the Earth.
What, does that have any effect on us when they hit us? I mean,
It happened 65 million years ago.
We know about- we
and,
know- we
and the
know-
dinosaurs
I've heard about that one, yeah.
didn't fare too well out of that.
so, but has anything happened since then?
There are smaller impacts. For instance, in the early part of the 20th century, 1905 or so, in Russia, there was
1908 or something?
something like
Yeah.
that. There was an impact by probably a stony asteroid, fairly small as these things go, probably only half a mile across or less.
Right. That was pretty immense. That
That blew down a lot of trees, and,
Right.
and it blew some Siberian farmers off of their porches and things like that. But it didn't blow up when it hit the ground. It blew up above the surface.
I guess they were lucky though that it hit somewhere that was pretty much wilderness.
Yeah, if that had been New York City in 2006, that would be a different proposition.
Or London, or,
Yeah.
or what if it hit in the middle of the ocean, or off the coast somewhere?
Most of them will hit in the ocean.
Yeah. Really? So how many hit a year or in a 10-year period?
It depends on the size you're talking about.
Yeah.
Things the size of this basketball hit the Earth several times a year.
Well, they're like meteors, right? Or
They're meteoroids when they're out in space. They're meteors when they're coming through the atmosphere and they're bright, and they're meteorites if they make it to the surface and you pick them up.
see, we see these doomsday scenarios on the Discovery Channel all the time.
It could happen. It could really happen.
But
It
wouldn't-
will. It's not a question of if,
I know, but-
really. It's a
but-
question of when.
But would we have enough warning? Would we have warning of something that big is on the way?
Well, people are getting more interested in these near-Earth objects, and so I think eventually we'll probably have some warning. Right now, I wouldn't bet on it.
Then again, if something really big came our way, what exactly could we do?
That's a good question. If we had enough warning, we might be able to do something if we had a plan in place, but there's, at this point, not much warning and no plan.
So, when you study near-Earth objects, what is the goal? What goal do you have in mind when you study them?
I'm just trying to characterize them in order to be able to make a good choice for the one we should go after with Hera. So I get infrared spectra, and that tells me things like what sort of minerals are on the surface, what kind of an object is it? Is it a object that has silicates on the surface, or does it have clay surface, or just what kind of an object is it?
What would you expect to find on the surface?
Oh, you'll find you'll find some rocks
is there
and
a
some
reasonable
metal.
expectation?
Yeah, most of these things have rock and metal and dirt of some type on the surface, and we'd pick that up with this little collector that we've got.
Right. So, is there anything that might just totally surprise you that might be on the surface?
You never know. This is exploration, it's research, and you really don't know.
I'm not saying like a sign that says "Yankee go home" or anything, but
No, we have our hopes and we have our thoughts, but we don't know.
yeah. How did you first become interested in this sort of thing?
I guess I was always interested in those things. When I was about 10 or 11, I remember I got one of these golden books on astronomy,
Oh, yeah.
and I got a little 2-inch refractor telescope and went out in the backyard and made a great discovery. I thought it
Really?
was outstanding, yes.
What
Of course,
was
it
it?
was Jupiter, but I thought I'd discovered something new there for a few seconds.
That's pretty cool, though. Yeah. How old were you?
I was about 10 or 11.
So, were you interested in the space flights when you were a kid?
Oh, yeah, very interested. Everyone was in those days.
So, which were you young enough for the Mercury space flights? Or
Yes, yes. One of the Mercury astronauts, Cooper, came from a town near where I lived in Shawnee, Oklahoma. So that was exciting.
What are your thoughts on the current space program?
What we need is China to go to the moon.
Why?
Then we'd have a space race. Everything is much more exciting if there's a space race.
It is pretty exciting if there's a space race, isn't there?
Yeah.
I remember back in the '60s, we were just and racing the Russians to the moon. And,
Yep.
Everything just kind of stopped after Apollo 17.
Well, after you've seen so many spacecraft go up, they start looking more alike each other.
Do you think the public has lost interest in the space program?
Some fraction of it has, and some fraction are like me and will always be interested in it.
Do you think, what would it take to get the public interested in the space program again?
I
The
think
Chinese
one
going to
thing
the
would be this push to take people, just ordinary people, up. We see some of that recently with
Space tourists?
Yeah, with the space tourists. When the cost comes down so that more ordinary people can afford to do it, then I think that'll generate a
Maybe
lot of
nicer,
interest.
like there's a lottery system and just take people, pull people's names out of a hat and take them up in space.
Yeah, some people would like to do that. Other
Yeah.
people wouldn't. I think it's too dangerous. And it is dangerous.
Well, yeah, I understand that. I guess the Russians turned down Madonna.
Wow.
I know. And she's such a shy person. It's hard to understand anybody turning down Madonna, But anyway, the Russians, they did that last week. They turned down Madonna. She wanted to pay the money to go be a space tourist, and they turned her down.
Wow.
But I guess maybe if the Chinese went to the moon, it would just scare people so much they demand we went back to the moon.
We're supposed to go. Just a question of time.
Do you think going back to the moon is a good idea, or do you think we should just bypass the moon and go somewhere else?
I think as an intermediate step, it's a good idea to go to the moon. We've had a lot of experience in near-Earth orbit now. Not nearly as much on the moon.
What do you think about the International Space Station?
Well, it's big. It's expensive.
Didn't something fall out of it today?
I think that probably came out of the shuttle.
Yeah.
I think that came out of the cargo bay. I don't know what it is. They'll figure it out, I guess.
What about the space shuttle itself?
Well, we've had them for a long time. They're getting pretty old now. We should probably replace them with something better.
Is that like using your grandfather's car to take your girlfriend to the movies?
In a sense, the older they get, the harder they get to maintain.
Some people say, why send humans when you could just send robots or unmanned
Well, there's some
vehicles?
things that are very difficult for robots to do that are easy for people to do, and vice versa. So I think both of them have their advantages.
If you had your druthers, if you woke up tomorrow morning and you were in charge of the space program, everything was like Claude Lacey's ball of wax, where would you put most of the emphasis? Or
I think most of it in robotic spacecraft. Less in human exploration, but some.
do you think human exploration is it like a stunt maybe, or some things, or?
Well, in the same sense that the Wright brothers' flight at Kitty Hawk was a stunt. I mean, in a sense it was a stunt, but in another sense it was exploration and innovation and research.
Do you think we'll ever really get to Mars?
We may. It would be very expensive, though, to send humans there.
Do you think we'll get there before the middle of the century?
That's a good question. If the Chinese get in a space race with us, I'd say yes.
Yeah. So if people want to go online, could they see pictures that Ursa? How is that? URSA?
Yeah, it's ursa.uark.edu is the website for Ursa, and they can see pictures that it's taken.
Really?
Yes.
Okay. So anybody can just
Anyone
go online
can do
and
that.
see that.
Yes.
Okay. Well, that's pretty fascinating.
There's also a similar site for the NFO web scope. It's www.nfo.edu.
What's the NFO?
NFO stands for NF Observatory. N is Neely, F is his first wife.
Okay. All right. Okay.
It's a brand. NFO is, NF Observatory, NF is a brand.
Okay.
And so it's actually NF/.
Okay. All right. Well, Claude, I want to thank you very much for being on the show tonight.
My pleasure.
All right. Thank you all for watching, and we'll see you next week.
Smoking gave me COPD, which makes it harder and harder for me to breathe. I have a tip for you. If your doctor gives you 5 years to live, spend it talking with your grandchildren. Explain to them that your grandpa's not going to be around anymore to share his wisdom and his love. I haven't figured out how to do that yet. And I'm running out of time.
You can quit. For free help, call 1-800-QUIT now.
Hi, I'm Walt Marshall. You're watching the Fayetteville Public Access Television.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish. Second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
off the limb now. That's one small step for man, one giant leap for mankind.
Springtime will break you into blossom. You got to crawl before you run. Shaky wings beneath the sun. Skeleton bird, too early for spring, my friend. Skeleton bird, never fly south again. Skeleton bird, a bird he knows when he's been good. He'd turn the soil now if he could. Bird he knows when he's alone. Pick myself out of his bones. Springtime will break you into blossom. You got to crawl before you run. Shaky wings beneath the sun. Skeleton bird, too early for spring, my friend. Skeleton bird, you never fly south again. Skeleton bird. Springtime will break you into blossom. You got to crawl before you run. Shaky wings beneath the sun.
The human figure has been one of the major themes of Western art, and it has been one of the themes that has attracted me ever since I began painting. This painting, Shadowed Figure, I did in the late 80s. I was really attracted by the way the shadows created the form of the figure, as well as somewhat clothed the figure. After moving to Arkansas in the late 70s, I began setting figures in nature. To me, they have a certain naturalness and a rightness in that particular setting, though I paint them in the studio and in houses as well. This particular one is set near my house on a beautiful creek that runs from the top of my mountain down to the Buffalo River, and I spend a lot of time at this pool and use models here. This has been something of a challenge for me over the years to figure out a way to use watercolor to create a a full modeled figure that has some of the intensity that the actual reality of a human figure has. And this I've always felt was one of my more successful ones. Some are better than others, and over the years I think I get slightly better at working at it. It's in the type of painting I do, these layers slowly built up, I have to work to keep a certain looseness and freshness to the quality that so that it has that lifelike feel to it. The particular problem on this painting I felt was to create that full feeling of form that a figure has while getting that atmospheric feeling of those shadows curving around the figure. It's an interesting theme that I keep coming back to again and again. Thank you.